Welcome to DD Maths tutorial, Mathematics Standard, Chennai region, section C, question number 31, subdivision B. So in the given figure, PA is a tangent to the circle with center O such that OA is equal to 10 centimeter. So let us note that OA has 10 centimeter and AB is equal to 8 centimeter. So this length AB is equal to 8 centimeter. Now AB is perpendicular to OP. So this AB, it is already mentioned in the diagram that it is perpendicular. Find the length of PB. We need to find what is this length PB. So first let us note that this is also a right angle triangle. So we can use Pythagoras theorem here to find what is OB's length. In triangle OAB, when we use Pythagoras theorem, we'll have hypotenuse, which is 10 square, is equal to 8 square plus OB square. 100 is equal to 64 plus OB square. OB will be equal to root of 36, which is 6 centimeter. So we have got OB's length to be 6 centimeter. To find PB, we are going to use the concept of similar triangle. So this is something similar to our example 3 in circles chapter, where we will be using AA criteria to prove that the triangles are similar and then take the corresponding sides of congruent triangles to be in the same ratio concept. Now to prove that the triangles are similar, we are going to take triangle OBA and triangle OAP. So let us see how we are choosing these two triangles in order. So O is a common point for both the triangles, that is a common angle for both the triangles, and OBA, this angle B, vertex B, it has a right angle. The same way vertex A in the other triangle has a right angle. So we have to take it in that order. OBA will be congruent to triangle OAP. So let us write that these two triangles are similar using AA criteria. So angle, we have it as angle O is equal to angle O, which is common, and angle OBA is equal to angle OAP because it is each of 90 degree. So now what criteria? By AA criteria, we can say triangle OBA is similar to triangle OAP. Now we will use by CBSE, which is corresponding parts of similar triangles. We will be having the sides to be in the same ratio. So instead of looking at the diagram and writing the sides, we can even look at this order and write it. So it is OB by first two letters, which is OA. So this is a simpler way to write the corresponding parts of similar triangles. So BA by AP, the same way the other two will be AO by PO. Now let us write what are all the measurements that we know. So OB's length, we know that it is 6 by OA is 10 and BA's length is 8 and AP we do not know. Let us have it as it is. So AP, first we are going to find what is the length of AP. Using that AP's length, we are going to find what is PB's length. So to find what is AP, once you cross multiply, we will be getting it as AP is equal to 8 into 10 divided by 6. So it is going to be 40 by 3. AP's length is 40 by 3 centimeter. So now we have this length AP, that is the hypotenuse of this triangle PAB, which is 40 by 3 centimeter. We know what is BA, we know what is the hypotenuse. Now we will be able to find what is PB using the Pythagoras theorem. So we will be having it as in triangle PAB, we are using Pythagoras theorem. So our hypotenuse is 40 by 3 the whole square, which is equal to 8 square plus PB square. When you square it, you get it as 1600 divided by 9. Transposing minus 64 is equal to PB square. Once you take LCM and simplify it, you will get PB square to be equal to 1024 divided by 9, which implies PB will be equal to root of 1024 by 9. Once you prime factorize and find what is the root of 1024, we will get it as 32, and root of 9 is 3, which can further be simplified as 10.666, etc., approximately 10.7 centimeter. So this part, instead of using Pythagoras theorem, we can even find PB's length by proving that triangle PAO is similar to triangle PBA, like how we did the previous one to find what is the length of AP. The same way you can use these two triangles to be similar and then use all the measurements that is given, that is already we know, and then find what is the measure of PB.